Let's see the next question in this exercise, question 713. Determine if the points, well, we have been given three separate points with the coordinates, whether they are collinear or not. That's the question. This problem can be solved using multiple methods. One of the techniques is to calculate the slope between first and second 2 points, calculate the slope line between second and third point. If the slopes are equal, the points are collinear. That's one way of doing it. But since this question is from the distance formula, we are going to use distance formula and solve this question. Since there are three given points, there are three possible pairs. When I select any 2 points out of these 3 points, there are three possible combinations. I can select these two, I can select these two, or I can select the first and the last one. In each case, we are going to use the distance formula and going to calculate the distance between these 2 points. We know that the distance formula is under root x1 minus x2 the whole square plus y1 minus y2 the whole square. This formula is symmetric. That means it doesn't matter whether you take x1 minus x2 or x2 minus x1. Whether you select this point first or this point first, it doesn't matter. It is symmetrical. Negative number when squared is going to give the same answer as if positive number equal if it is square. So let's take the three pairs individually. Let's take the first and second number points and let's calculate the distance between them. I will count this as x1, this is x2, sorry, this is x1, y1, and this is x2, y2, x1, y1, x2, y2. So if I plug in these values here, I'll get 1 minus 2 the whole square and plus 5 minus 3 the whole square. Well, upon simplification, I get 1 minus 2 is negative 1, 5 minus 3 is 2, 1 square minus 1 square is still plus 1, 2 square is 4. So this will give me 1 plus 4 under square root, that will be root 5. Now I can take the second and third point, that combination, and I'm going to use the same technique, calculate the distance using distance formula. Here, this is x1, y1, x2, y2. So it will be 1 minus of minus 2. Here you have to be careful because we have negative coordinate. 1 minus of minus 2 and then 5 minus of minus 11. Both brackets squared and eventually everything is square rooted. So 1 minus of minus 2, that will be 1 plus 2. So that will become 3 square. And 5 minus of minus 11, that will be 5 plus 11, that is 16 square. 3 square is 9, 16 square is 256. So altogether this will come out to be square root of 265. The last combination will be the first point and the last point. So let's write them down. This point, 2, 3 and minus 2 minus 11. So again, I'm going to use the same formula. 2 minus 2, 2 minus of minus 2, that will be the first square. And 3 minus of minus 11, that will be second square. 2 minus minus 2 is 4 square. 3 minus minus 11, that's 14 square. 4 square comes out to be 16. 14 square comes out to be 196. Together they will be 212. Now once we have calculated these three individual distances, the question is whether these 3 points are collinear or not. Let us assume for the time being, hypothetically, that these points are collinear. So how will the diagram look like? I'm going to draw a straight line and let's assume that point 1, 2 and 3 are the collinear. That means they will lie on one single line. They are exactly points on one single straight line. We don't know yet, but for the time being, let's assume that they are. If that is true, then the longest distance between the farthest 2 points, let's say this red dot and this red dot, whatever is the distance, the extreme distance will be simply equal to the addition of the two smaller distances. So the largest distance, if it is equal to sum of the two smaller distances, well, then we can easily say that with sufficient confidence that these 3 points are collinear. Let's check whether this condition is being satisfied in this scenario or not. The largest of these three numbers is root 265. You have to ask yourself a question whether that is equivalent of the sum of the remaining two smaller distances or not. Let's check. Is root 265 same as root 212 plus root 5? The answer is, well, I don't see any correlation here. Upon simplification, there is no guarantee that this will be equal to this one. 265 is way higher than 212 plus root 5. So I'm going to say not equal to. Since the distance is not cumulative, that means the distance doesn't add up. The two smaller distances combined does not give to our larger distance. That means we can come to a conclusion that the points are not collinear, and that would be your final answer.